Hello, community. Welcome to this monthly technical community call about Hedera. My name is Ed Marquez. I lead the developer relations team for Hedera at Hashgraph. If you're joining us for the first time, if you're new to this community, I do want to provide a little bit of context. Hedera is an open source, EVM compatible proof of stake layer one network, and Hashgraph is that entity driving the engineering and marketing initiatives for the Hedera network. And so today we have a very exciting set of topics to cover. We're going to talk about a couple of Hedera improvement proposals that are going to be impactful to that EVM experience on Hedera. And we're also going to cover some new developments for tech folks out there. Now, before I introduce one of the guest speakers, I also want to cover housekeeping items. So the first thing is we are live streaming this session to multiple platforms. So be sure to share it with your networks, with your friends, and with your colleagues as well. That also means that a recording is going to be available. So if you want to watch at 2x speed or watch at a different, more convenient time or share it with others after the fact, that's something that you're most welcome to do. And I also want to share some general reminders about the structure of community calls that we have for the Hedera network. So we have 3 different community calls. 2 of those happen every month. Every month we have a general community call. And every month we also have a technical community call where we talk about things for devs, things that are coming from the Hedera Improvement Proposal process as well. And then every other month, we also do a call for our Spanish-speaking community. So that is also very exciting to join and seeing that community thriving. Now, I also want to give kudos to our team behind the scenes to make this type of call possible. So for me and Luis, big shout out. And also to the DevRel team and all that team working on the implementation of HIPs and also the contributors that bring those HIPs to the table for consideration and implementation. So we can probably start the slide share here. And I'm super excited to introduce or to welcome Nana to this call. Nana works in the engineering department at Hashgraph. So at this time, I'll let Nana introduce himself and maybe tell us a little bit about his involvement with the Hedera network and what he focuses on today.
Yeah, hi. It's a pleasure to be here. Thanks, Ed. So like Ed said, my name is Nana Isofikondia. I'm a director of software engineering at Hashgraph. I have had the fortune of being with the company in different variations for, I think, almost 6 years now. I joined end of 2019, a week after the network went live. So I had the opportunity to work on the Mirror Node team when I started. And then I led the smart contracts team for about 2.5 years. And now I'm really excited to work on a new initiative called the block nodes, which you guys will hear about in the community more. But yeah, it's a little bit about me.
That is amazing, Nana. Thank you for sharing that. And we can go to the next slide. So this is going to be the agenda for today. As I mentioned, we're going to cover 2 HIPs. One that is going to be zero cost Ethereum transactions on success, and the other one is going to be jumbo Ethereum transactions. So that's the part that Nana is going to cover. And then we'll focus on the Hedera Developer Playground, which is a great tool for those who are looking to get started with Web3, get onboarded with Hedera, and also even existing Hedera developers. Now, also related to housekeeping, we will be taking questions. So there will be a Q&A probably halfway through the session. So feel free to drop your questions in the chat. We'll be looking at those. And then we'll also have some time towards the end in case you have any additional questions. All right. With that in mind, Nana, over to you.
Yeah. So let me see. So maybe some context setting. I don't know how much everybody knows about Hedera and other items. So throughout the overview, I'm gonna give some base knowledge as well. Hopefully that's useful to a lot of people. But yeah, I have the pleasure today of giving you an overview of 2 HIPs. HIPs are Hedera Improvement Proposals. Specifically, I'm going to be talking about HIP 1084 and HIP 1086. And these are both within the frame set of improving the efficiency and cost around Ethereum transactions as they relate to relayers on the network. So a bit of context as well. So Ed had already shared that Hedera is open source. We're open source, we're proof of stake, EVM equivalent blockchain. We're also enterprise grade scalable, and we hope to be the trust layer of the internet, right? And so HIPs, as I mentioned, are improvement proposals. And so these are suggestions and ideas from the community, us included, that go to improve the efficiency and user experience as well as functionality of the network. I do want to give a disclaimer that everything I'm about to share, it might not come in the final form that I'm suggesting. And so the nature of open source is that there's a lot of democratic processes that ensure that improvements to the network consider everybody, everybody on the call, depending on your use cases, whether it's, financial, gaming, DeFi, etc. Right? And so what that might mean is that the suggestion that I'm sharing, though good, it may not be the best one at the end of the day, right? You guys might have better solutions or other ideas. And so we take that into account in discussions. And so the final form of these HIPs may not be as presented. So I don't know when it will go to mainnet, go to testnet. So I just want to, say that not to give anybody any false promises or anything. Also, one item there is that let me dig a bit into the open source nature of the network, right? So Hedera contributed all the code that specifies the network to the Linux Foundation Decentralized Trust. And under that trust, the code is known as the Hiro Ledger, right? And so all the developments that you'll see in the future will be mostly contributed there. And Hiro has what we call a technical steering committee. So that's TSC, and they meet almost every week. And, those calls are open. People on like you on the call that might be interested in that are able to get on these calls, give your opinions. And as I mentioned before, they're going to take into consideration all the different personas of the network and how does this help somebody or how does this not. And once the TSC is happy with that, they would, approve a HIP that is proposed. After that, Hedera, which is, the deployment, or as you like, of that code, also would decide to accept that HIP in that form. And so you have a couple of touch points where these ideas can be fleshed out and improved. And one of the items I wanted to call out here is that there is a call to action, right? You as a community member can share your views. And so all of these improvement proposals are on GitHub. They're at the Hedera Improvement Proposal repo. And as they're put up, you can make comments on there. You can say why you like a HIP. You can say why it might not be the best fit for you. We take into consideration all those things. So I do encourage people to follow the HIP process and share their views on that end. So with that in mind, let's talk a bit about EVM equivalence. EVM equivalence, I think, across the Web3 industry is debated, that definition. But for me, it's really the ability to conform to the EVM API, right? So the Ethereum virtual machine, even though it's called Ethereum, there's a virtual machine that's a separation from the actual network. And so I see the conformance of the API specifications, meaning that you are EVM equivalent. And for us, that's really important because we want developers and users to be able to sort of plug and play, right? Bring their contracts from other EVM networks over to Hedera, right? And so our goal there, like I mentioned, is to bring, to encourage developers, product owners to bring their applications over. And one of the ways we do this is to attract them with the speed, right? So Hedera, as you might have heard, offers really fast speeds. Natively, we can transfer value at 10,000 transactions per second. On the EVM side, we come to somewhere around 10x, right? What you might see on other networks. An interesting point there is that our blocks are every 2 seconds, right? So you might be on another network where it's a longer block time and slower, right? So you could submit multiple transactions on our network while you're still waiting for another network's block time to complete, right? Another way in which we might attract and try to tell developers and other builders is, superior or, extra cryptography, right? So the EVM specifies the ECDSA cryptography key type, right? And that's good. But Hedera natively supports that and more. We also support the ED25549 cryptographic key. And we do some interesting things as well where we support key lists. Key lists are really the ability to say that a transaction needs to be signed by multiple keys or all the keys in a list. We also have support for things like threshold keys that could say that, hey, you need to sign with at least 2 of 5 keys on an account or on a transaction for this to go through. And it gets really complex and really interesting because you can nest these requirements. And this is something that we do natively. And more recently, because of other HIPs, we've actually also been able to expose that to other smart contract capabilities as well. So EVM developers can utilize at least the verification of this for their smart contract processes. Another way in which we try to encourage and attract people to come over is the cost. Hedera offers transaction and network support at a fraction of the cost, right? Most of our transactions vary in cost between, I think, about a cent to like, a third of a cent, depending on what you're doing. But, the fact of the matter is that you could send any amount of HBAR on the network to anybody for a third of a cent. And a third of a cent is 0.0001, right? And so I started my, I'd say my blockchain development somewhere like 2016, 2017 as an Ethereum developer contributing, building dApps and other smart contracts on there. And I had this interesting experience where I had this paid project where I was trying to do a demo for a customer. And that day I felt very brave to do sort of like a live demo on the testnet. And I kid you not, I had to wait about a minute to a minute and a half for this transaction to go through whilst I was trying to convince this paying customer that this was the right way to go. If you had told me then that I could take those same contracts and deploy them to Hedera and that I would get finality in 1 to 3 seconds, and I wouldn't have to be looking for future blocks to see if this went through, or the fact that I could get all the results of my transaction within about 5 seconds, I would have jumped over in a heartbeat, right? But also not just jumped over. Right now we have multi-chain solutions, and so this is the goal here for EVM equivalence on Hedera is to offer builders another chain to which they can push their smart contracts and also bring their user base. So with that in mind, let's talk a bit about the EVM transaction flow itself. So usually what happens is that an EOA, that's an externally owned account, that just means that this account's ownership is prescribed by a cryptographic key that needs to sign, right? And so that would be me or you taking MetaMask and submitting a transaction. Usually what happens is that you would submit that transaction to a relay. A relay would take your transaction and submit that to an actual, consensus node. The reason being that it's just easier for the relays to know which consensus nodes to push to. And as a user, I don't want to keep track of IPs and other things, right? Some notable relays would be, Validation Cloud, Alchemy, Infura, Third Web. You've probably heard of these and used these. On most EVM chains, there is no cost to the relayer for submitting this transaction, right? Because the cost of the transaction is captured in gas that the EOA pays. And so for most relay operators, the business model for them is covering the cost of operating that node in whatever cloud environment they are at, and moving those costs and covering them in different ways. If we look at Hedera, that's a little bit different, and for good reasons. With the benefits of low fees and highly performant consensus models, we do a little work upfront, and it's important for the availability of the network and also its efficiency to make sure that we cover that charge in a secure way. And so what that means is that anybody that's actually submitting a transaction to the network has to pay a small fee as a submitter, regardless of how the transaction goes, whether it's successful or not. And so even though it might cost only a third of a cent, the interesting thing is that a third of a cent is way more expensive than free, right? And so relay operators that are coming from another network over to Hedera, they have to factor that into their business model, right? And so what happens there is that as the relayer submits more and more transactions, their cost goes up. So consider a relay that supports hundreds of thousands or even in the future millions of transactions a day, right? They have to cover that cost somehow, and it's something that they need to factor in. Another difference is also the transaction limit. And so on Hedera, one of the unique things is that we have a 6 kilobyte transaction limit on transactions. It encourages, smaller, more thoughtful transactions, but it's also one of the ways in which we're able to, cover the 10,000 transactions per second. There's a bit more to that, but that's sort of one of the architectural decisions that were made. One of the ways in which we support larger transactions or larger entities is the Hedera file service, right? So you are able to create files in the network by using multiple transactions. So I might create a file and then append bytes to that file continuously until I get to the size of the file that I'm trying to represent. And this is actually how relayers today support large Ethereum transactions. And so today, if a relay was trying to process a transaction that is, deploying a large contract or maybe feeding in large call data to a contract, maybe let's say it's an Oracle price feed update. Usually this size is a lot more than 6 kilobytes. The way the relay gets around this is by creating a file, appending to it based off of the necessary size, and then submitting an Ethereum transaction that says, hey, go pick up the call data from this file. The result of this is that the relayer, again, has to cover extra costs on Hedera that they wouldn't have covered on another network. So over there, when you put these two things together, it presents some ecosystem challenges for relay operators, right? So the EVM equivalent side of this made it so that developers and users had a really good experience, right? They didn't have to think about it when they moved from one EVM chain over to Hedera. But the result of that meant that, what we saw was relay operators did have some friction, some considerations to make. And we think that this contributes to what we're seeing today, which is, not as many relays in the network as we would expect, but also in some cases, not enough free relays as you would see on other chains. And as I mentioned before, it's just, in a sense, financial logic where a business will try and cover its costs. And so sometimes what you'll see there is that a relay will provide a subscription fee right up front, right? And so you might ask somebody to come over and play around with Hedera, and they would be looking for a free relay, and they might be pressed to find one. But as I mentioned, we do have some really good relays on the network, Validation Cloud, and others there. And so, we thought about this for a while. The challenge here is we want to continue to support a really great user experience with fast and cheap transactions, but we would never do this at the expense of network security, right? So we will always favor, securing the network. We will always favor keeping data secure and making it open and accessible to users. And so we try to think about how we could do this in a performant way. And so this is where the solutions come in, right? And so this is HIP 1084 and HIP 1086. And so 1084, let me start with that one, is the zero cost Ethereum transaction on success. And so really what we're saying here is that if we know that an EOA pays gas for the transaction, and that's good, and that's sufficient, then so far as a transaction submitted by a relay to the network is successful, and success here is the EVM processing it, then there's no need to charge for that transaction. And so what this means is that if a relay submits a well-formed transaction that's gone through certain pre-checks and everything goes through and the EVM processes it, then we don't need to charge that relay any fees. If that relay submits a bad transaction, and bad being, poorly formatted, or they didn't do certain checks on, does the user have enough balance to pay for it, those sort of things, the network will still charge that relay for the work that it does in checking that transaction. And so over here, the responsibility is on the relay to check the transaction. And this is actually what is done on other networks anyway, right? So if you look at Ethereum, relays also do these pre-checks. And if you utilize the open source Hedera JSON RPC code, you already have this covered for you as a relay operator. So there's not much extra to do. But the onus, again, becomes on the relay to make sure that it's submitting well-formed transactions. Otherwise, it will pay for them. But if everything is good and it's done the pre-checks, then it's only the EOA that has to pay it. And the relay no longer has to pay for that transaction, just like they would expect from other EVM chains. And then there's HIP 1086, which builds upon HIP 1084. And so 1086 is jumbo Ethereum transaction. So jumbo just meaning large, right? So if we've covered the fact that on a normal transaction base, if the transaction is well formatted and a relay submits it, it's good. We then need to cover what happens when it's above 6 kilobytes, right? On other EVM chains, contracts can go, or call data can go up to about 128 kilobytes. And so that's what we wanted to go for initially. And then again, we want to make sure that the EOA covers that, which is standard across that. And so what this HIP is saying is that, okay, in the case of a jumbo Ethereum transaction, the network will provide an exception for an Ethereum transaction and will allow call data up to 128 kilobytes, and that an EOA will cover the cost of all of those bytes. One of the interesting ways that we go about this is that the consensus model basically looks like, or at least the part that refers to this, is consensus nodes gossip what we call events. And these events are a collection of transactions. The events themselves have a size that's permittable. And usually these events are made up of really small 6 kilobyte transactions. And so we thought, what if instead of all of these transactions being small 6 kilobyte transactions, what if we take up the space of, a couple of these 6 kilobyte transactions with one of these jumbo transactions? And when we realized that we could do that, we realized that there would be no impact to the consensus model, and that we'd still be able to support the current speeds that we're talking about. And so this is one of the innovations or realizations that allowed us to propose 1086. And so again, what would happen is that if a relay receives a large transaction, it would be able to submit this. The network would see that it was a jumbo transaction, and it would take that space up as appropriate and charge the EOA as appropriate. And the relay, again, itself would not have to pay the cost of this. And so in summary, really trying to resolve the challenges that a relay operator faces. With 1084, we remove the cost of a transaction so far as it's well formed. We put the onus on the relay operator to ensure that it's doing pre-checks, which are well defined in the industry, and the EOA pays for the transaction in the form of gas, as would be expected. And the same with 1086. That being said, the extra call data or the extra bytes are also covered by the EOA so far as it's well formatted, and the network should be able to cover the same speeds that we manage with everything else. And so that's those two HIPs. I hope that was helpful and informative.
That was amazing, Nana. Thank you so much for that overview. Well, we give a chance to the questions to come through the chat. I had a question about 1084. How can we expect what kind of impact can we expect for the user experience in relation to HIP 1084, right? Like, what do the relay operators see, and then what do the end users see with that implementation of this HIP?
Yeah, good question. So to a user, both 1084 and 1086 would be seamless and invisible to them, right? They're not going to see any difference. And actually, to a relay operator, it should be the same for 1084. They actually wouldn't have to take any changes so far as they already have those pre-checks supported. So as I mentioned, with the open source code for the JSON RPC relay, that's already implemented. So if you're running that code, those pre-checks have been there for a while, and we've added a few more recently just to make sure we have everything covered. But to a relay operator running that latest code, they wouldn't have to. To a relay operator doing their own implementation, just like they would on any other chain, they would have to do the pre-checks in there to cover it. You didn't ask this, but it's related. For 1086, again, it would be invisible to the user, but the operator would basically have to update their code. If they had existing code using the file system, they could remove that code. But again, if they're using the open source software, once this HIP goes through and those changes are made in the open source, again, it should just be a case of updating the version of the software, and that should all be covered for them. And so they should, in both HIPs, just see their costs of operations go down.
Awesome. So just a comment here, we did share a link to our documentation that has different information on the relay operators. So that is available to you. So you can see some of the relay operators in the ecosystem, like Nana mentioned, Validation Cloud, there's Third Web. We have Hashio, which is a hosted service by Hashgraph. But again, that one is for testing and development purposes. And there are a few others you can check out in that documentation page. Also, Nana, one more question. I was very curious when I heard this. So with the jumbo Ethereum transaction, we're going with the transaction limit from 6 kilobytes to about 128. And then you also mentioned that that is not expected to have an impact on the throughput and the consensus of the network. Can you tell us more about how that is possible, or what's going on under the hood there?
Yeah. So kind of as I mentioned, today nodes gossip between each other, right? And so an event is a collection of transactions, and today, I don't remember the exact numbers, but let's say there's a given space, a threshold in which an event size could take. That event is usually, as I mentioned, a collection of those 6 kilobyte transactions. So instead of, let's say we had an event size, again, this is not the number, but just for example purposes, let's say we had an event size that was, 200 kilobytes, right? And so up until then, we've done, let's say 200 divided by 6, you can fit about maybe 33 transactions in there. Instead of doing maybe 33 transactions, let's say we have the full 128 kilobyte one, right? And let me see, I'm just doing some quick math. That leaves us with about 72 kilobytes. That 72 kilobytes can be distributed across normal 6 kilobyte transactions. And so in that case, that event could take one large jumbo Ethereum transaction and about 12 normal size 6 kilobyte transactions. And so under the hood between nodes, the amount of data being gossiped out hasn't changed. And then therefore the performance should be around the same. But to the users, as we mentioned, we can now support these larger jumbo transactions.
Awesome. That is a great explanation. All right, so there's another question that we'll save for the overall Q&A towards the end so that we can start transitioning. And then I see a comment from, a very influential figure in our ecosystem. So Action, I see that you're on X and asking if you'll see us at HederaCon. Hopefully, yes. If you're going to be there, we'll be there. We're both going to be at HederaCon in ETH Denver. So that's probably a thing to mention, towards the closing and also the housekeeping. Next week at ETH Denver, we're going to have the first Hedera user conference since 2018. That is HederaCon. And so it's going to be a great gathering of influential minds. Lehman, Mans are going to be there, and other founders, and a lot of people from the Hedera ecosystem, including community projects and folks from engineering, developer advocacy. So a great opportunity to meet and network with folks from the Hedera community and ecosystem, Action included. So you'll get to meet all those folks there. All right, so at this time, let's transition now to talk about the Hedera Developer Playground. So I'm gonna share my screen here. And this is something that came to the Hedera ecosystem on January 23rd. So it's only been a few weeks, but this is a fantastic tool because this is all it is a browser-based application, a website that allows you to learn and experiment on Hedera without doing any local setup. It's all done from the browser. And in fact, we're gonna do some live coding here. So hopefully everything will go well. But you'll see how easy it is now to get started. And even if you're an existing Hedera developer, how easy it is to test different ideas and prototype and explore. And so if you haven't checked it out before, make sure you go to portal.hedera.com/playground. And this is the interface that you're going to find there. We're going to do a tour of that once we get to the demo part. Now, in terms of what this is and what it enables developers to do, I like this tool because it enables you to write JavaScript and Java code right on the browser. You don't have to install anything. And then over time, we're going to be adding support for more of those Hyro/Hedera SDKs. They used to be Hedera SDKs. Now they're Hyro SDKs. So we're going to bring support for languages like Go, Swift, Rust, and C++ and other languages. So again, if you're one of those existing developers that already knows Java, JavaScript, you're coming from the Web2 world, or know colleagues that are coming from those languages, it's very easy to get onboarded and get started with Web3 and Hedera. And of course, you can do very simple individual code snippets that help you learn and understand individual features. But at the same time, you can combine all of those and create more complex flows and little scripts that create a sequence of events. So we're going to see examples for both of those as well. And as I mentioned before, this is a game-changing platform for both new developers and existing Hedera developers. So I think it is very important because it enables that fast onboarding to help you get faster in the learning in the Web3 world. You can also get more done much quicker. You don't have to, think about local setup if you're just trying to deploy something for the first time or explore. And then you can do that prototyping in a matter of seconds or minutes rather than, hours if you're trying to try your best ideas. So with that little bit of context in mind, let's just go ahead and start coding on the Hedera Developer Playground. So I want to start in this view of the playground. Right now, this is what everybody would see. Even if you're not a logged in or registered user, anyone can come here to this interface. And you can start basically adding code in this front end so you can see and understand, the different functions, methods that you have available to work with. One of the things that I love about this is that this is actually embedded on the Hedera developer portal. So we're going to see the logged in view once I'm able to do that. But you also have the ability to log in if you have an existing account, or if you don't, you can start building and you just have to register for a testnet account. So I already have a testnet account. I'm logged in. So let's just switch back to this view. Let me zoom in a little. And we can change, the size of the text, play with the different UI elements that we have here. So let's do a tour of this UI. Now, I do want to have a disclaimer here. What you see is an example of what not to do. Make sure you keep your private keys private. You don't share those. But for the purpose of this example, this is a burner account. So I'm going to change those keys immediately after the session. So starting with the tour here, you have your account menu where you can, look at your personal access tokens, look at your account profile, and so on. And one of the advantages of having this developer playground embedded with the developer portal is that you get this integration to the keys that are available to you through this portal, right? So you can work with ED25519 keys or ECDSA keys. I tend to prefer ECDSA keys. And here you can select the language for now, supporting Java and JavaScript. In addition to authoring the code and executing the code, you can always share that with colleagues. In fact, I'm going to share with you a few of the examples that we're going to do today. You can copy the code and also download your application file. So we're just going to stick to Java, but also transitioning between these two languages. So if you already have an example in JavaScript, you can very easily transition that example to a different language like Java. So if we think about the examples that we're going to do, actually, before jumping into the examples, I also want to show you this faucet and dashboard, right? These are tools that are available to you through that portal. So here you see your account credentials for testnets, like the main testnet and also the preview net. And you also have access to this faucet. So this allows you to anonymously get 100 testnet HBAR every 24 hours. So it's a very good way to create accounts or to refill your account if you prefer to get started without, going through the registration process. All right, so now we can jump into the examples. And what you see here in these menus are the different capabilities or services that are supported. So you see that this supports transactions and queries for account and HBAR, the Hedera consensus service, token service, smart contracts, even scheduled transactions, and a few miscellaneous utilities as well. So I want to start with highlighting some of the unique capabilities that Hedera provides, right? Things that are common in the Web3 world, but very unique to Hedera as well. So the first thing that I want to show you how to do is how you can create an account and update it so that that account is multi-sig, right? Nana mentioned key lists in his presentation. And on Hedera, you can have accounts that either have a single key, they can have a key list where maybe if you have 3 keys, all 3 of those have to sign to approve transactions, or you can have a threshold key. So say 1 out of 3 keys can sign. And you can also have nested structures for more complex workflows that maybe reflect real world hierarchies. So here, let's just go ahead and create an account. So this is a new account in addition to the one that I have here in the portal. So we can think of this account as Alice's account. The first step is to generate a private public key pair, and then we create that account with the account create transaction. Then we set the alias for the account, and we set the key to the public key for that account, right? And this is going to have an initial balance of 10 HBAR. We then execute that, we get the receipt and other information to display that to the console. So we're going to run that in just a second. The other thing that I'm going to do now, I'm going to cheat a little bit because I have this other code already ready so that you don't have to watch me type too much. But what we're going to do to update this account and make it multi-sig, right? This is going from a single key to a threshold key. That's what we're going to do. We're going to generate 3 key pairs, right? So private public key pairs. That's the code that generates those. And then in addition to that, we're going to create this empty array of keys, and we're going to push those public keys into that array, right? So now our public key list contains those 3 public keys. And here is how we create that threshold key. We do so with the key list class of the SDK. We're going to make sure that that gets included in our imports. And here's the variable where that we have as a public key list. So now that we have that array of keys or that key list, let's update the account so that it becomes multi-sig. In this case, what we said in the comment is, let's just make 1 out of 3 keys sign. And so we can get rid of this code since we already have our keys. And one little change that we have to do here is we have to make sure that this new account key that we created gets specified as the account that we're going to pass in the account update transaction. Here's a requirement where our new key, at least one of the keys, has to sign this transaction, right? To rotate the keys of this account. So here we're signing with the old key of the account and any of the new keys. So let's say maybe key number 3 is the one that signs this transaction. And then we have some information that we want to bring down here. So we're just going to say new account key. And this is, I believe, public key list. All right. So this should run. Again, just to summarize, we created a new account. We created a key list, and we made that a threshold where only 1 out of those 3 keys has to sign. And that key list is now the new account or the new key for that account. So let's run this. This is live, so anything could happen. But just like that, in just a matter of minutes and a few clicks, we were able to, again, create that account and update it so that it's now a multi-sig account. And if we look at this transaction information on Hashcan, here we see that transaction details, timestamp, payers, transfers, and all of that. But here I want to go to our account ID, to the entity that we just created in this step. So we can see it's 261. There is our account 261. Here's the equivalent EVM address for that account. And here we can see the key type or the key structure for the admin key of this account. And so you see it's a threshold key with 1 out of 3 keys. All right. So that is just one example of a common application. So keeping an eye on time, I do know that we have some time for additional examples. So I want to show you some additional things that we could do here. So now we can clear this code and we can move on to maybe a new example of something that is also very unique to Hedera, and that is the scheduled service or the scheduled transactions. Now you can think of a scheduled transaction as a little package, a transaction that you form, but that is not executed immediately. It's only executed once you collect all the transactions that are required for that signature to go through. And so that can be very useful if you want to, have automation without the need for smart contracts. And you can even schedule transactions 62 days into the future. So very important feature for enabling that automation with the native Hedera services and native Hedera capabilities. So just like before, let's create a new account. Let's imagine that this account is Alice, right? So that's the code that we had before for the account creation. Now let's create that scheduled transaction. We can look in more details of what's happening here. So the scheduled transaction, as I mentioned, it's like that little package that you're forming. And inside that scheduled transaction, you have to specify the transaction that you're scheduling. In this case, it's going to be a transfer of HBAR. I want to make things interesting. So this is going to be a transfer of HBAR from that account that we just created to my account. So this is going to be account ID. We have to make sure that the signs and quantities are correct, that they add up. So that new account is going to have an initial balance of 10 HBAR. Let's say I want 5 HBAR back. So that person is transferring, Alice is transferring 5 HBAR from her account to my account. And if we were to execute this right now, nothing would happen, right? Because we just created the schedule, but no signatures. Alice hasn't signed the transaction for it to execute. And so now we just have to add a sign transaction here. And we just have to make sure that we specify the right schedule ID, which we got from the previous step. We're using the schedule sign transaction class from the SDK. And here, the key that has to sign, I believe it's account private key. This is the equivalent of Alice signing or authorizing this transaction. So once more, this is live. Let's see what happens here. And if we execute the code, there we have it. So we created the account. We can see the details for that transaction, the details of this new account. Here is the transaction that created that schedule. We can view that on Hashcan. And more importantly, here's the execution of that transfer. That could have happened 60 days into the future, 30 days, 3 days, 30 minutes afterwards. In this case, we just did it right away with Alice providing her signature for the purpose of the example. So again, you can see the schedule create transfer and then the child transaction that took place. So the transfer of 5 HBAR minus fees from Alice's account to my account. All right. We can clear our example here and let's move on just to the final example for the day here. To keep it in threes. So I think a common thing and also a very unique thing is the Hedera token service, right? Which allows you to tokenize anything as a fungible or non-fungible token without the need for smart contracts. Now, if you want the flexibility and programmability of a contract, you have the EVM available to you that will work with many open Zeppelin contracts with ERC standards as well. But in this case, I just want to create a token using these Hedera SDKs. And it literally just takes about a click. So in this case, we're just going to create a fungible token that uses the token create transaction from the SDK. Here we can call it community call token. And here there are certain required fields. So make sure those are going to be provided for you or filled out for you from the playground. But if you want to look at the additional options that you have available for each one of these transactions, be sure to inspect this transaction menu, the queries menu as well. And then you can come here to this question mark and view the documentation that you have available to create that token, right? So that'll tell you things like signature requirements for the transaction. It will tell you what methods are going to be required and which ones are going to be optional. Okay, so that is a very convenient feature of the Playground, that it allows you to get the knowledge and the information that you need right at your fingertips there. So in this case, this our symbol is going to be a fungible token. My account is going to be the treasury, right? So kind of the entity or the account that is going to deal with the initial supply and minting and burning for this token, an initial supply of 5,000. And here we go through the rest of the steps of signing and executing this transaction with our client to send it to the Hedera network. So just with a single click, we were able to create this token. So one last time, we can look at this information on Hashcan as well. And we can see this is the information about the transaction. So that initial mint or initial supply that took place. And here we can see the additional details for our token if we were to have characteristics for these different properties or values for these different properties. All right, so those are the examples that I wanted to cover for today with the Playground. And then here I want to share these resources with you as well. So this, is kind of the recap of what we just did. So we made an account multi-sig. We also worked with scheduled transactions, and we created a token. We didn't necessarily create mint and associated transfer and NFT. This is a more comprehensive version of that last example that we did. But here you have additional examples to simply create a Hedera account, create an account and transfer HBAR, and then also transfer via allowances. That is also something that is supported natively and through smart contract for HTS tokens and for HBAR as well. All right, so that is the overview of the Playground and the demos. And at this point, I want to remind you to go and visit portal.hedera.com/playground if you haven't already. So that concludes the content that we had for this meeting. So let's keep an eye on the chats and see if there are any questions. Nana, any initial thoughts or questions? I was sweating when I hit execute every time with these live demos.
Nah, you did good. You did good. I think I missed the comments section, so I'm not sure.
All good. All right, so I see a few questions that came in earlier from Stan. So the first one is, are community nodes completely off the table for Hedera?
I don't have too much information about that, but I could say on the roadmap, it's definitely in consideration. I think, as I mentioned, with the HIP process, there's now a lot more thought that goes into it and making sure that it works for everybody. And so I don't think it's being removed. I think it's still under consideration. I just don't know in what form. And I think the community chipping in with ideas, as well as the higher ledger technical steering committee and Hedera's TechCom, will get more answers to that.
Excellent. I see that there are a few general questions. These might not necessarily relate to the HIPs, but we'll do our best to address them here. So the other question is, are there any updates for DREC? So I can start maybe providing a little bit of context. I don't have like a tremendous amount of information on DREC. I know that just to provide the context, DREC is a protocol that came from Dr. Lehman Baird, right? One of the co-founders of the Hedera network. And it stands for decentralized recovery. So a way to have a safety net for secrets in the world of Web3. One of the things that amazes me of Web3 is that if you lose your keys, you kind of lose your value. In other realms of life, you have sort of a backup to recover things that are valuable to you. Your passwords, your bank balances, maybe your keys. If you lose them, or you can call a locksmith. So there's always a backup. Whereas in Web3, this is a very intense problem that if you lose your keys, you lose your value. And so that is what DREC aims to solve. And it does it in a very smart and simple way. And so what came after the technical protocol was an alliance, the DREC Alliance, that seeks to bring together players from the Web3 ecosystems. So I know that there have been other protocols like XRP Labs, I believe IOHK Labs, obviously Hedera, Hashgraph, and many other projects that have come together as part of that alliance to implement that protocol and start rolling it out. I don't have the latest information on where the implementation is, how close it is to going to market, but probably something where we can keep an eye on. And as we learn more information, that will be shared directly from the DREC Alliance. So just to clarify, the DREC Alliance is also a separate protocol, right? The main relationship with Hedera is the fact that it came from Dr. Lehman Baird, and there was an involvement from the Hedera protocol and Hashgraph as part of that DREC Alliance. So let's keep an eye on those channels from the DREC Alliance for any new updates on that. All right. And then the last question I see is Hedera an active participant of the President's AI initiative? I assume that is speaking to the United States. I don't have a lot of information on that. I think that's a little bit removed from the, day-to-day development and development focus activities that are within my purview. So I would say maybe monitor general channels and so on for that kind of information. Nana, do you have any insights on that?
Nope, I do not. I think what you said carries.
Excellent. All right. Another question that came from Bite-Sized Learning is there a place where I could find projects utilizing the DIT service offered by Hedera? You just gave me a fantastic idea with that question. And so there's a resource that I do want to share with you. So let me share my screen once more. This may directly answer your question. I think perhaps your question warrants a follow-up just for more specifics on what you're looking for. But what I want to point everyone to is this awesome Hashgraph repository that contains a very comprehensive list of resources, documentation, use cases, infrastructure and integrations, and so much more. And so, again, if you're a dev, you can come here for information on docs and training, articles and presentations, different GitHub repositories that would be interesting to you, and even some of those different tools, integrations, and infrastructure that you would be interested in as a dev. If you're looking for use cases, this is the section that would be good to check out. So different Hedera projects, and this has been categorized by real world applications or real world digital asset tokenization, DeFi, RWAs, payment, sustainability, data integrity, and AI, and so much more. And so I believe some of these projects may be using the DID SDK, but that's probably something that, if you shoot us a follow-up, we can try to connect you or share more info on those projects that we know of that may be using the decentralized identity SDK. All right. I don't see any more questions coming through. I thought this was a very informative discussion. So thank you so much, Nana, for the time, for the overview. That was very valuable information to share with the ecosystem.
A pleasure.
So, awesome. And thank you to our community for joining us today. If you have any feedback, please let us know in the comments, topics that you may want to see more of. Again, the focus of this technical community call is things for developers, things that are technical. So more than happy to consider those topics that may be of interest to our technical community. So with that, we'll bring the session to a close, and I hope everybody has a fantastic rest of the week.
Thanks.